Get up. So please, in a moment, make very welcome Kate, who is a PhD student in archaeology at Flinders University. Her research interests include geochemistry, chemistry of pigments, and how scientific methods can be used to better understand the past. And I think that's what she's going to be talking to us about tonight. So please make Kate very welcome.
Am I able to remove the microphone from the stand because I am far too short for these seats? Beautiful. Hello everyone. Thank you for Ash for that little introduction. As Ash mentioned, my name is Kate. I am a PhD student in archaeology from Flinders University, and today I'm going to be talking to you about how science can help us understand medieval art. And my research on the high crosses of Ireland and the Isle of Man. Slide, please. So you're probably thinking, I came here to hear about physics and chemistry. What am I doing here listening to an archaeologist? And it's true, as an academic discipline, archaeology falls under the remit of the humanities, since ultimately it's about using artifacts from the past to understand human behaviour. However, in its application, archaeology draws on all of the hard sciences, geology, chemistry, physics and biology, to answer questions about the past. It's almost like it beats up real sciences in dark alleys and goes through their pockets for spare methodology. And personally speaking, archaeology is a great vocation for a wannabe scientist with no aptitude for maths. So my research centres around high cross monuments. So these are monuments dating from the 7th to the 12th centuries and are unique to Britain and the Isle of Man. My focus is on the monuments in Ireland and the Isle of Man. So these are tall stone pillars up to 6 metres tall, and they're carved with intricate scenes of biblical stories and geometric patterns. So it was originally thought that these were supposed to be painted, but today no pigment is visible on these monuments. So before I get into the science about what I'm researching, I'm going to give you a little, this is exactly what you wanted for an evening of science, I'm going to get into a little bit of art history. Thank you for the musical interlude. So why do we think these monuments would have been painted in the first place? Well, stylistically, they're very, very similar to other artworks that were created around the same period, such as metalwork and manuscript illumination. I'm not going to try and figure that. So some of the most famous illuminated manuscripts from the early medieval period in Britain and Ireland, such as the Lindisfarne Gospels and the Book of Kells, we see the same stylistic treatment of the human figure, as well as geometric pattern and the use of motifs and artistic devices. So for example, you can see here on the slide, in the Book of Kells on the left, you see an artistic device which is used to energize the figure, which is a spiral in the shoulder of a figure. Okay, you can see it replicated in stone here. We also see the repetition of motifs, such as these men pulling each other's beards, and my personal favourite, hats, which are ubiquitous in the Book of Kells and on the high crosses as well, in particular those in Ireland. Another argument is that a lot of the high crosses were carved out of granite, which is a notoriously difficult stone to carve into any sort of fine detail. So instead we see, in a lot of instances, figures like the one here depicted, which is of the biblical scene of Daniel in the lion's den. So the bodies are depicted as formless blocks. Since this looks a little bit silly, and it's hard to read as intending to represent a person, particularly from a distance, it makes a lot more sense if the clothes and body of the figure was painted onto this block. Another more compelling example is this one here from the High Cross at Moon in Ireland, which depicts the scene of Joseph and Mary fleeing into Egypt with baby Jesus. So stylistically, it's almost identical to this wall fresco here which is from Muster in Switzerland. So this indicates that they would have had to have been based on the same stylistic source. So again, you can see here, the body of Mary is depicted as just a formless block, with just the head of little baby Jesus poking out above her shoulder here. So if the artist wanted the audience to understand that baby Jesus was being held in front of Mary, then these details would have to have been painted on, and in fact it would have been sacrilegious for them not to have been painted on. Slide please. So how can we determine if these monuments were originally painted if there's no monuments left, no pigment left to be seen on the monuments? Well, that's where the science comes in, and thank you for being patient with me while I get there. So the technique that I'm applying to these monuments to try and find traces of pigment is called expofluorescence. So the beauty of this technique is that it's non-destructive, so we can apply it to these monuments, and it's not chemically changed or altered. So a lot of the time when we are using chemical analysis techniques on artwork, we can't use destructive sampling because that would damage the artwork. So this is the ideal technique for use in this instance because it doesn't damage the artwork we are trying to analyze. Oh, go back. Oh, good. So I have done some experimental work using this technique to try and determine at what concentration these pigments are no longer detectable to the XRF, and they can be found in extremely low concentrations in the pores of the stone itself, and even in instances where the paint themselves has been scrubbed off, we can still find traces of pigment in the stone, in the pores of the stone itself. So there is a good chance of, when we analyse the data, of finding pigments remaining on the high cross monuments. So how does expofluorescence work? Well, I'm glad you asked. So the instrument emits radiation in the form of X-rays, which interacts, is the GIF working? Yes, it is. Beautiful. Which interacts with the electrons circling the atom or the nucleus of the matter that is under analysis. So what it does is it energizes or ionizes an electron in the inner shell of the atom, which is then knocked out of place. This makes the atom unstable, and so to correct itself, what it does is it replaces that inner shell electron with one from an outer shell. This releases energy. Okay. Each element releases a different characteristic energy, which is then read by the instrument. This can then be displayed as a spectra here, which looks a little bit like a graph, and then we can go along that graph and we can identify each of those peaks as a discrete element. Now, the technique isn't perfect, so sometimes when we identify pigments, they can be ambiguous. XRF can only detect the elements and not the compounds of the pigments under analysis. So that means that if we identify lead, for example, that can be a red paint or a white paint. We then need to use the context of where we have found those pigments to try and identify the pigment. For example, the backgrounds of important figures are more likely to be painted white than red, or images of flames are more likely to be painted yellow than green, for example. Okay. The technique also can't identify organic pigment, unfortunately. Since organic material is made out of light elements like carbon and oxygen, XRF can't detect these. This means that it discounts some important medieval pigments that would have been used, such as woad and madder. Once we have obtained our spectrum, we can then compare these to instances where destructive chemical sampling has taken place, or from recipes, medieval recipes for pigment, to try and identify what the elements we have found, what pigments they would have belonged to. So this is a little example of the template I'm currently working from. So So once we have identified the pigments, what can that tell us about medieval art, particularly on the high crosses? Well, the biblical scenes on the high crosses aren't easy to identify. And in fact, most of the academic scholarship today has centered around trying to identify the biblical scenes on these crosses. So a lot of medieval art uses iconography, which is kind of a codified way to identify the characters depicted. So for example, the Archangel Michael might hold a sword, or St. Anthony might hold a loaf of bread. However, iconography isn't always consistent, and a lot of iconography relies on colour. For example, a lot of medieval depictions of Jesus have been depicted in red robes, as you can see from this example here in the Book of Kells on the left. Sometime in around the 13th century, the Virgin Mary started to be depicted wearing a blue cloak, as you can see here from this 13th century French manuscript Illuminating. It's not entirely sure when, why, or how this particular colour became associated with Mary. And so it would be super interesting to be able to identify this pigment associated with this character in an earlier context. So ultimately, the point of my research is I'm interested in whether identifying colour on these monuments can help with identifying some of the more contentious scenes on the high crosses. So why is that important, I hear you ask? Well, as you can see by the blocky figures that I pointed out earlier, the artists originally intended from the outset that these monuments should be painted. Okay? Therefore, seeing them as we do today, unpainted, is tantamount to seeing them in an unfinished state. So what I am doing with my research, or what I'm hoping to complete with my research, is that I'm going to use the colour schemes and the paints that I have identified to recreate partial or complete colour schemes for the monuments. These can then be applied to physical replicas and displayed alongside the original monuments in museums and at heritage sites, so the audiences can understand what the monuments would have originally had looked like. You can see here we have some speculative ones done by my supervisor John McCarthy, but I must point out this was just him playing around on paint. He didn't have any kind of scientific evidence as to what colours would be applicable. It also has some really interesting applications for VR and augmented reality that could be applied in museums or at heritage sites, so that people can understand what the artist intended the monuments to look like and understand them better as artistic works, both within a modern context and their original medieval context. Any questions?
Let's give it up for Kate. Thank you, but that talk is unlike anything I have ever heard before. That was really, really cool. Do we have any questions from the audience? Awesome, we have a roaming mic somewhere.
He's not a plant.
If not, I can see how long this lead is.
Oh, it's working.
No, there we go, good.
Hi.
Hello.
I'm just wondering how far back you could go with this technique. Its limitations on the pigments. At what point would you no longer be with it? Could you go back another 1,000 years?
So I'm glad you asked that, and I forgot to mention this earlier. So a lot of my methodology is based, as all science is, a lot of my methodology is based on previous work. So there has been work done and partial reconstructions of painting schemes done on Roman sculptures from the Antonian Wall along the Scottish border. She used a multi-instrument technique, so XRF was one of the techniques she used. So I'm kind of pulling on that and seeing if I can refine her XRF methodology a bit further. But yes, it has been found on Roman monuments in Scotland, which are about 2,000 years old. Sorry?
Rome was actually why I was asking.
Yes.
And then another question out
What
there.
have the Romans ever done for us?
No, it was a similar question. I was going to ask, has there been like...
Sorry, where are you, speaker?
Back here.
Back.
So is there any contemporary painted models that are in existence that you can examine with XR in order to determine whether or not those colours match up?
Yeah, so my experimental work, we have been using paint from medieval recipes. The thing about medieval paint is it was made from extremely toxic chemicals. So the paint that I have using was arsenic trisulfide and mercury sulfur and lots of lead-based pigments. So it's extremely toxic chemicals that are typically found in the stone that we're looking at. So we can do that by comparing it to a control. So when we're using a control on the monuments, we look for broken surfaces, or sometimes if it's a single-sided monument, we can take a reading off the back of the monument. And so when we analyse the surface of the stone, we're looking for peaks in comparison to that control. Does that answer your question?
I'm going to call that a yes, based on...
say if not, because I'm happy to keep talking.
Alright, we got another question over there.
I was just wondering if the same technique could be used to replicate with ochre and other types of paint?
Absolutely. So ochre and iron-based, ochre is iron-based, by the way. So yes, we have done that. I have done that. So ochre is one of the pigments that would have been used in the medieval period, both for red, brown and yellow pigments are all based on ochre. There has been some talk of trying to do it with indigenous rock art as well, but that's still a side hustle.
Awesome. I think we are out of time for questions, unfortunately, but Kate's not running away, so feel free to come and grab her in
If you
one of
have
our
more
breaks.
questions, I'm pliable with drinks.
Yeah. Us scientists will never say no to the opportunity to talk about what we do. So please, one final thank you for our amazing first speaker. All right, we are now going to play a mini game before our next speaker, so I'm just going to get you to